Okay, so welcome back for the actual code part of it. Okay, so now what I'm going to do for you is I describe to you Python topics, inheritance, object-oriented programming, classes, objects, instances, what it means to have functions and data attributes of a class. What we're going to do now is we're going to start running. I'm going to show you a small basic code, and the focus of this code is not to run this. I mean, this is a very simple piece of code. What I want to show you is I want to talk to you about the essential elements of constructing a Pytorch script. Okay. There's many ways people use Pytorch. One of the simplest is to run it in something called Jupyter Notebook. How many people familiar with Jupyter Notebooks? A lot. Very good. So for those of you who didn't raise your hands, why don't you find somebody who did raise their hands and ask them how it works? It's pretty straightforward. And you can get up to speed with Jupyter Notebooks in just under half an hour at the most. Okay. Jupyter Notebooks are very nice because what they allow you to do is to interact with codes. And what it does is it allows you to interact with codes in parts of it. So you can have a little part of the code, run it, see what happens, and then move on to the next part of the code, write it, or just run it all over again. So there's a sequencing to your code that Jupyter Notebooks allow. What we are going to use over here is something called Google Collaboratory. So Google Colab was something that we shared, the link we shared with you, and I hope most of you have used Google Colab before. Again, those of you who did not raise your hands, please find someone who did raise your hands and ask them how to help you. The Google Collaboratory is something that this code is written in. Again, if you're looking for other ways, other IDEs, integrated development environments in which to write these codes, you can use as little as Notepad or Notepad Plus or Emacs or Vim, your favorite editor, and you can get up and going with this. You have to have a Python installation on your computer, and you have to have Pytorch installed. Okay, so we will go over some of these things just very quickly, but in more detail on Friday when we do the hands-on lessons. I will expect you to have an active Python environment. So if you are comfortable if you know what virtual environments are, and you want to set up your own Python setup like Anaconda or something like that, you're very welcome to do that. There's other IDEs like Spider and PyCharm. My personal favorite is PyCharm, but we won't be using any of those here. What we will be using for the sake of uniformity, we'll be using Google Colab. Okay, so even when you do the tutorials on Friday, we will do it in a way that you will use Google Colab. But know that this can be set up into a much more wide scale setup in a much more professional environment where 2 or 3 people might be working on this code. The other thing that I want to talk to you about before I actually get into Pytorch is the use of AI pair programmers. So how many people have heard of this word before? An AI pair programmer? If you've heard of GitHub Copilot? Okay, how many people heard of ChatGPT? ChatGPT, okay. ChatGPT. So the notion of a pair programmer in programming is to have 2 people programming together. They're all staring at the same piece of code. One person is writing, the other one's overseeing it, overviewing it, giving direction to the code, and then they switch responsibilities and continue to work on it. This sort of helps the team of 2 people to, one focuses on the writing aspect of it, the actual making sure that the syntax is all correct and so on. And the other person gives more oversight, overview, more direction to the code. And then when you switch, that's just for balance of responsibilities. So this notion of an AI pair programmer arises from the fact that now code can be your pair programmer. You can have something like, this is one of the most famous implementations is ChatGPT. There's also GitHub Copilot. So these things are becoming very, very popular, and they're becoming very, very handy to use and very widely available. So I want to say a few words about using pair programming, but use it responsibly. AI pair programming means that you want to use something like ChatGPT to help you with your work, like as if you had a human pair programmer along with you, which means that you want to ask it for some syntax. You can quickly type it in your ChatGPT window. Can you offer suggestions? What are the syntax for a particular question? Okay, and then you will see that I will show you a little demo of how to do this in the Friday session when you're actually doing the hands-on thing. And you will see that you can use prompts to generate relatively large pieces of code. Now, I want to say a word about the ethics of this. The way you want to use pair programming with ChatGPT, we'll use ChatGPT. I believe GitHub Copilot is a paid program. So we'll use ChatGPT to generate boilerplate code. Boilerplate code is code that is pretty straightforward, routine stuff, but it just takes a lot of time to type out. So to ease that little bit of effort, you want to use ChatGPT. So boilerplate code is something you can use ChatGPT for. Ultimately, what I want, there are two rules that I teach my students. One, you can use ChatGPT, but you have to acknowledge it in print during a program, during our paper writings and so on. And the other thing is that ChatGPT is not your author. It's not even a co-author. Okay? So if anyone's interested in reading up more about this debate of what is the view of how ChatGPT should be used in academia, there's a very nice Nature article on this. I'm not sure if it's an editorial or an opinion article, but you can look it up. We can discuss it in class as well. I mean, during these lectures as well, or we can discuss it offline as also. So acknowledge ChatGPT and don't treat it as your co-author. What it means is that the responsibility of writing correct code is on you, the human. The human is responsible for writing correct code. ChatGPT can make mistakes and does make mistakes, okay, all the time. So you can use prompt engineering to help you along with codes, especially boilerplate codes, and the code for which you don't want to run into copyright issues with, like you don't want to plagiarize somebody else's code. So the general feeling in from what I've read seems to be that code that you copy from ChatGPT is not considered plagiarism, provided you follow the other principles that I've laid out. So we will use ChatGPT when we need to for writing boilerplate code. But what that means for us is you will have to take the responsibility of whether the code is correct or not. So you have to understand code. In almost no situation can you simply take code from ChatGPT, ask it to write the code for you, start running it, and write professional programs. I think that that's a no-no. And I encourage you to develop your own style of using prompt engineering. But I would say that you have to understand the structure of code and not use it naively. You have to use the structure of code, you have to be able to edit it, and ultimately the responsibility that the code is correct is on you. Okay, so that being said, let's dive into Torch. So what is Pytorch? Pytorch, is that too loud? Okay, you let me know if it's too loud. So Torch and Pytorch. Pytorch is Python versions of Torch. It's a neural network library. So which means that it allows you to do a whole lot of things. You saw in the previous talk, a very nice talk in which you saw a number of neural networks were used for solving medicine related radiology issues. And so how do we go about starting to write one of these networks for ourselves? So what we're going to do is we're going to study this thing called the ImageNet dataset. ImageNet dataset is a small dataset where handwritten, sorry, not MNIST, M-N-I-S-T. My mistake, I apologize. We will use the MNIST dataset. And basically, these are images of size 28 by 28 pixels. I assume everyone knows what a pixel is. Yeah? And some letter is scribbled on it. For example, an 8. Okay? So there's a lot of these images. They are either 0 or 1 or 2 or so on and so forth till 9. And the goal is to be able to take an image like so, feed it to a trained network. You have to train the network, of course, and be able to get very high accuracy in reporting the output, whether the scribbled 8, the image which shows 8 is of category 8 or not. Okay? So we've got 3 things going on over here. On the one hand, you've got the image itself. Your output has to be categorical, so which means does it belong to the class of all 8s, right? And if you wish, you'd like to be able to say that the digit corresponding to the number corresponding to the class, the categorical class 8 is the number 8. Just know that these are differences. There are differences whether you ask for a categorical output or whether you ask for a numerical output is up to you. And you're going to have to worry about this. If you worry about taking all of these MNIST data sets and categorizing them into one of 10 categories, then you're solving a categorical problem. Categorical problems are often known as classification problems also. If you care about, so in this case, whether you solve for a numerical number or whether you solve for a categorical number, you're still solving a classification problem. You have a whole bunch of images. You'd like to be able to sort them into certain categories in a supervised manner. Okay. So what we're not going to use the entire data set. We're only going to use the digits 0 and 1, images of the category 0 and images of the category 1. Okay. So let's talk a little bit then about how Pytorch is organized. So Pytorch is a full-fledged package, and it provides modules and it provides submodules. You don't need to know the details of all of these things, but as a full-blown package, it provides you various hierarchies, various subsections, sub-elements, and so ultimately you're looking for a function. That function may be part of a module. A module may be part of, maybe a submodule is part of a collection of modules, and so on and so forth. So Pytorch is organized in this vast structure. Okay? Most of the time, we don't need to worry about this. Where we actually interact with this Pytorch is essentially in these sets of lines over here. So we import packages. We import the package torch. We import sub packages. Torch.nn, for example, is a sub package that contains torch. You can imagine the torch is a larger, it's a parent, and you've got some child sub packages. NN is one such package. It contains modules and utilities for building neural networks, right? So some neural network, NN is still quite a big, quite high up there. Then you've got optimizers, and you've got utils, and you've got torch vision, and so on and so forth, right? So most of this is going to be boilerplate code, right? When you look for something, like for example, if I'm looking for something called data loader, which I'll describe to you in a minute, I need to know where to get it from. And you go look it up, and it is found under torch utils.data, and then you just import the data loader class. Okay, so so the syntax is from the correct parent import data loader, or from torch vision import transforms, and then you can use transforms in your code. Okay, you can import torch.nn, and there's a sub facility called functional that's under torch, that is under nn, which is under torch, and you can import it, but you can also change the name of it. Instead of typing the whole thing or even functional, you can type f. So that syntax is import as f, or you can import a lot of people will have used matplotlib. So matplotlib.pyplot imported as PLT. So these are pretty straightforward syntaxes. Most people seem to use the same thing over and over again. So like PLT becomes a very common acronym to use. Of course, you can call it something else, but many people, if you see PLT, the first thing your mind goes to saying is, wow, that must be matplot pyplot package. Okay, again, F, it's very common to use this functional as F. Okay, any questions? Again, I'm just glossing over this. If you really want to dig deep into the hierarchy structure of Pytorch, you're very welcome to. All of this is open source. You can go look up the documentation online. You can actually open up the package structure, the package directories, and you can go to town on studying the structure of it yourself. For the purposes of using it, we will only rely on importing most of this. Most of these are very commonly used. You probably end up importing all of them anyway. Okay. Okay. I'm going to skip this section for a little bit. I'm just going to tell you what it does, and I'll come back to it. Okay. So this is not magic. All I'm saying is I'm actually taking the MNIST data set. I'm downloading it. Okay. I'm applying a very silly little transform called transforms.toTensor. So Pytorch works on tensors. Okay. Again, I won't give you a detailed view of tensors right now. When we get to the lab, we will, in the hands-on session, we'll talk. I'll give you a couple of exercises to work on tensors. You need to know a few things about Pytorch tensors. Basically, the Pytorch tensor is essentially like a matrix. It could be one-dimensional, it could be two-dimensional, it could be three-dimensional, and so on. We won't use the entire. We won't need to know all of it right now. But you do need to know a few things, which I will cover in the hands-on session. Essentially, think of matrices available. If you've seen a NumPy array is very, very close to. How many people know NumPy? Numerical Python? A lot of you. Okay, so a tensor is very close to Python. Tensor is very close to a NumPy array. There are some differences in transferring back and forth between NumPy arrays. If you want to cast from a NumPy array to a torch tensor, or the other way around, you have to be careful of a few things. But as you go along, you learn those. So it's not too bad. So long as you realize that you're using a NumPy array and or you're using a torch tensor, and I will show you this thing, how to discover that as we go through this code. You'll be fine. You'll know if the two shapes match or not of the tensor, and so on. That's really where it comes up. Okay. The other thing that I'm doing is I'm only picking out select classes. So I'm creating a train data set and I'm creating a test data set, and both of them are filtered so that I ignore all the other classes except zeros and ones, all images of type 0 and all images of type 1. Okay, so we can discuss this in more detail if it comes to it. But so the first thing that occurs when you want to talk about how do I get my data in, if you want to start working on this problem, what do you do to get the data into your packages or into your framework, whatever you're using, so that you can then write torch code to process it. Okay, so the easiest way, one of the ways in which you do it is to create two folders. I'll create a folder and I will mark it, or let me call this, and I will place all images of 0, 1.jpg, 2.jpg, and so on. I'll place all the zeros in one folder and I will place all the ones. These are the two classes. Notice that the names of these two folders is zeros and ones, and the images that are stored in this are, let's use a different a.jpg. So I create two folders. One has all the 0 images in it. I create another folder which has all the 1 images in it. And this is a very simple data format. And Pytorch provides you direct classes to upload this data into your, I also want to point out that sometimes I use this book. This book is titled Programming Pytorch for Deep Learning by Ian Pointer. I don't have any recommendations whether it's good or bad. I just use it. If you have any better book to use, you're welcome to. You should know that as with all software, the release changes things. Every next release will change things, right? So whenever you're picking up a book like so, you must know which what is the underlying software version that you're working with for this book. Otherwise, things may not just work. They just may not work, right? So, so there is, yeah, back to what I was describing. There is something called a dataset class, and I'm looking for the syntax. As you can see, I don't remember syntax. So I always have to look it up, which is fine because you can either ask a pair programmer to do it, or you can look up the documentation. It's not a matter of remembering anything. What you get used to, you get used to. So I want to write torch vision dot data sets provides so this let's say there's a directory called train. Torch vision.datasets provides a function called image folder, for which if you pass the string, the root is equal to, I'm assuming I'm in a parent directory. I'm in the directory train. If I pass it the directory train, then it will automatically pick up this data set for you. And what is created is an object called, I can name it anything I want. Let's say I call it train data. Okay. So this is how you get a data set. It is derived from the class big data set. And this image folder is a child of that, I think. So in any case, the image folder allows you to pick it up. This particular code is showing that there's actually a function called mnist, for which if you provide root is equal to that dot data, train is equal to true, it will pick the train data set. If you say provide train equal to false, these are all arguments, right? In functions, which you recognize now. If you provide train is equal to false, it will get you the test data set. And don't worry about the transforms. Download is true, which means that if you don't have this, download it. Okay. All right. So I have actually already downloaded this. Now, when you write up this code, you see this thing on the. You can actually change the name over here. It's in Python notebook. So it's got this IPNB extension. If you click this thing over here, it's a symbol that says run, which means let's run this cell. Okay, so this whole thing is a cell. Okay, I don't want to run this one. I'll run the next cell for you. Okay, so you see the cell. Now let's go to the next cell. Okay, so there's this cell-wise operation, cell-wise execution that you can carry out in a notebook, which most of you have seen before if you use Jupyter Notebook. And in Colab also, you're going to first, so once I download this data, I'm going to leave it alone. I don't really need to download this over and over again. I mean, every time I make a change to my code, I don't want to be downloading my data all over again, right? So now that I have downloaded it, and there's some internal structure of how and where Google Colab will store it. If anyone's interested, we can discuss it offline, but that's not terribly important for us. This data set is small enough that it will be, you can store it in the directory, in the free space that Google Colab allows you. Okay. How to enhance that directory is something we can discuss later. But I need to point this out because some data sets, as you saw, can be huge, and then you won't necessarily be able to work with Google Colab for that. You might have to create your own either space where you work with very large models, or you might need to switch to a different system. So Jupyter Notebook will work perfectly well if you've got local space on your machine. That's another way in which you can work these things. Okay, so I created that upper cell created two folders. So what happens when you actually load this in? Okay, you get a data set class and you get labels. So you get images, and images will be stored in a certain way, and you get labels, and labels will be stored in a certain way. Okay, so labels, you might just say that this is a string label with 0 or a string label 1. Okay, so for every image that came from here, you would attach a string label to it. Okay, right? And for all the images here, you would attach one label to it. All of these images, you would attach another label to it. I hope that's clear, right? Okay, so that's what you want. That's what you do when you load this data into a training, into train data variable, okay, into a train data object. Now, so you've loaded the data. Let's say if we've loaded the data and you want to see whether this data is reasonable or not. So you might pull out a few images from this entire data that you've loaded, and that's called a batch. So taking a small piece of your data is a batch. You might take a batch of 4 images, you might take a batch of 8 images, you might take a batch of 16, whatever you might just have a batch of 1. This batch is also going to be useful for you when you actually train data. So you can train data when you run training. You can ask for a comparison to. You can have the loss function evaluated on the entire data set, or you can have a loss function. Loss function is the function that will basically take your training data and it'll compare it to the outputs. So let me back up. The machine learning engine is essentially saying, well, here's my neural network. Here's my input. Here's my output. Call it label. Compare it. Okay. You pass your input to your neural network, get an output. Okay. You also pass the label by passing the neural network, and then you ask for a comparison between the label, the prediction, that is basically a function applied to your input data, very complicated function, but a function nevertheless. It's a mathematical function. So what you've done is you've carried out a series of operations and then produced an output. Okay, and that output has to be a number. Okay, I'll show you in a little bit that it can be a probability number, or it can be something else. So it turns out to be when you get one number and you've taken your other number, you encode this number as, you encode this label as a number, you can compare these two numbers. And if they're based on if there's no difference between these two, well then there's no difference between giving a label and passing it through the neural network, right? Which means you've done well. Your neural network has produced the right label you expect to see. If there is a difference, then that information is sent back to tweak the weights of the neural network. The weights of the neural network are the changeable parameters. You've got connections all over the place, and the weights, how strongly one is connected to the other. Those are the weights. Those weights are changed by a technique called gradient descent. So what gradient descent is a very simple, it's a very general technique which says you have a loss function, which gives you a loss landscape. And you're supposed to move in that loss landscape. So this difference is called the loss. Should we use something else? You've got some loss landscape. Not very good at drawing this, but imagine that these are deep valleys, and those are places where this is high and so on. So you're moving in the loss landscape somewhere until you find yourself in a local minimum. And then you stay in that local minimum. If you've got a reasonably good local minimum, you are doing well with respect to, let me say that again. The better you are doing with being in that local minimum with respect to the training data set, the better your chances are you will do it well with on the test output. However, as in all machine learning, there's going to be a bias variance trade-off, and your generalization may not have the same level of accuracy as your training. So training loss in general, training loss means the loss that you compute on the training data. Training loss in general will go down. Let's just leave it annoyingly ambiguous for now. What is happening here? I'll fill it in. The training loss typically goes down, and with very deep networks, training loss can be exceedingly small. Your test loss is loss that you compute on things you've not seen before. So what you're trying to do is you're trying to take a training data set and trying to run the neural network through a gradient descent problem until you find yourself in a minima. That minima is a low value of loss. If it's a low value of loss, you say then now let me try and apply what my output will be on something I've not seen before. That's generalization. That is computing the test loss. When you see the test loss, typically the test loss will go down as a function of training, and eventually it tapers off. And then you can't do any better. Okay? There are many nuances related to whether the validation or test loss tapers off, or whether it takes up, and there's a second phase of it falling down. There's a whole slew of these things. If anyone's interested in double descent problems and so on, you can talk to me outside. That's not within the scope of this. Typically, we'll have test loss taper off, which means I cannot do any better than that. Training can stop. Okay, so that's where we are trying to get with this. We won't get quite that far right away. Let's get back to what we were discussing. You've got data, you've loaded it in, you've got your test data. Now the next thing we are going to do on the test data, at least for the sake of Pytorch, is I'm going to create a data loader class, a data loader object. So a data loader, I'm going to run data loader. Data loader is available as torch, util, data, or data loader. That's, if you look back up, you'll see that, that's one of the things we've imported all of the way. So we know that this torch, utils, data loader is being called. I'm going to send it the filter data set. Remember, my filter data was training data sets, but only keeping zeros and ones. So that my problem is a binary problem. Okay, I'm sending in a batch size of 4 and shuffle equal to true. This shuffle equal to true means scramble the. So I have a data set. I have to pick out 4 of them, scramble it, and pick out 4. Otherwise, you would go first 4, second 4, third 4. So it's up to you how to use shuffle. I'm setting it to be true. I don't care in the order in which things are arranged. I'll just shuffle it around, pick 4 of them. So that gives me a batch of that is a train loader. A train loader, a data loader is an iterable object quantity. Iterable means it will provide you iterations of as you take the data, you want to be able to generate an iteration over this. Okay, so the technical term for this is to create an iterable. Data loader is an iterable over the data set class, data set object. So it provides you a way of running through batches. Does that make sense? Okay. So data loader is a Pytorch class that provides an iterable over a given data set. So data set class by itself is just a collection. It's a collection of data. If I provide you an iterable, it will load data samples and batches. And this is very effective in using in running training. Okay? And this will feed data to the model during training and evaluation in batches. The batches are going to be something that are terribly important for us. 4, a batch of 4 at one go. 4 images. 4 images and their labels will be available to whatever process we are running at one go. And then if I walk through, if I iterate over this, which I'll show you in just a minute, it's right here, I'll show you in just a minute. As you iterate over this, you will get one batch of 4, another batch of 4, another batch. If I shuffle, then the order is not guaranteed to be reproducible from run to run. Otherwise, it's in sequence if I say shuffle recurse. Okay, so I'm going to describe a dictionary of classes. And again, this is some really simple boilerplate code, so I won't belabor this, right? All this is I'm going to define a function called plot images and their labels, which will take in images and labels as arguments. Where will those come from? That's going to come from here. I'm going to take my train loader. I am going to ask it for a batch of 4 images, and then I'm going to plot the images and the labels with this function. Okay. So I encourage you to write this code. I actually used ChatGPT to write it. I was too lazy to write it myself. Okay. But as you will see, when you get, if it were GitHub Copilot, I could give it a prompt and it would tell me, well, what's a good way to plot images using matplotlib. Okay, so where do you have to be careful here? You have to be careful. You have to know the format in which things are stored. And you also know which package you're working with. Okay? So for example, a brief primer on how images are stored in most numerical libraries, be it pyplot or be it NumPy, EIL. What's a good, or MATLAB for that matter? What's a format in which you think images are stored? How would you store an image? Yeah, PNG is a format. JPEG is a format, right? If you wanted to store the raw image, it is essentially a square of pixel values, right? And depending on whether you're storing grayscale images or if you're storing RGB values, you can have one layer store the red information for you. So each is a number between 0 and 255. Okay, which represents the range over which you can get why 255? It's a bit less. It's a byte. So what's the right byte size that you get 256 images stored? Work it out for yourself. It's some power of 2, right? Which power? You can work it out yourself. So you have a small byte available to you for each one of these pixel values. Okay, so that's R, the red value. You will have another such matrix for G and another matrix for, look, so if you want to store an image in RGB format, you basically have 3 planes. And what's the size of this matrix? Size of that's the size of the image, right? So width and height are the image sizes. If you have a megapixel image, what does that mean? Okay, you can work it out. What's a 3MP camera? You can work it out for yourself. Okay. If you have a grayscale image, this is known as the number of channels. So if an RGB image, there are how many channels? 3. If you have a grayscale image, there's a particular linear combination of these 3 channels that you can use to convert from an RGB image to a grayscale image. A grayscale image has 1 channel. So you have to keep track in your torch tensors. You have to keep track of two numbers very carefully. The width and the height is pretty easy, right? In our MNIST data set, this is 28 by 28. Remember, each image is 28 by 28 in MNIST. I don't know if I said that, but if I haven't said it, it's 28 by 28 images, 28 pixel by 28 pixel. Okay, and these are all grayscale images. So channel will be just 1 channel. And the other thing, the other number you have to keep track of is the batch size, which the batch index and the batch size. So batch index is really what you're after. So the batch, let's say I've chosen a batch size of 4. I've got yay big a data set. Okay, I know each image is 28 by 28, 28 by 28, 28 by 28. Each one of those 1 channel, 1 channel, 1 channel, 1 channel. So I know there's a uniformity with respect to that. What I don't know is in my iteration, when I'm at this batch or this batch or this batch or this batch. So there's a batch index that is kept track of when you run through a loop. Okay, right? So there are 4 essential numbers that you have to keep track of. And the funny thing is, the annoying thing is that if you go between NumPy and Pytorch, you often get the indices mixed up. So for Pytorch, the storage is 1,28,28, and you can run in all sorts of trouble when you mix and match all these packages. Sometimes you have to be careful. You're wondering, I gave you a perfectly reasonable image, you didn't give me anything out. It's only because it expected it as 28, 28, 1, not 1, 28, 28. So you have to keep track of that. And you get used to it after a while. But what I'll do is I'll show you functions where you can grab that information from an image. Okay. So we wrote a little, me and my AI pair program, we wrote a little this thing function. Okay. Now here's the workhorse is here. Get a bunch of images and labels from the train loader. So train loader, iter on it, gives you a data iter. It means I now have an option of running next on it, which means that iterate over data iter. Data iter is an iterable. Iter over it one at a time. So if I iterate, I'll get a batch of 4. And what should I assign it to? Well, I'll get labels and I'll get images, right? Remember my data set packed of 2 quantities? It's got images in it and it's got labels in it. So I'm going to take all the images and place it in this, comma, labels, place it in the next variable, right? That's convenient. That's very nice. So who can tell me what the size of images is? What is the size of this images, not images as in generalized images? What is this size? What will this be? Say that again. 1. I have 1 image. The batch size is 4. I think the batch size I wrote was 4. Maybe it's up there. It's a batch size of 4. Payload has all my data set. See, so the concept is this: my data set has everything in it. All the class, all the images and all the labels attached to it. I'm putting an iterator on it to get iterations in batches of 4. Okay. So I created a data loader class, which is an iterable, and then I ran next on it to give me 1 batch. So what's the size of that object? 1 cross 4. No, think about it. How is your images stored? How can you store an image in 1 cross 4? Say that again. So is it 1 into 28 into 28, or is it 28 into 28 into 1? Okay, so which is why this is an extremely important thing to remember. Okay, what am I asking? I'm saying images is an array. I pick out its first object, so I bracket off 0. That gives me the first object in what could be a multidimensional array, right? And then I'm going to ask for its size. Is this a function? You can see that there's a parenthesis on it, right? So images will give me first element of images. Images itself has multiple, it's a vector, it's a tensor. Okay, let's go through this and see what the answer is. Torch.size 1, 28, 28. Now, what is this 1? And what's 28, 28? 28, 28 is easy. It's a height and width of each of these images. So this plot images labels worked. I sent it I sent it a tensor images, and I sent it labels. The labels gave you 0, 1, 1, 1, and you can see that they correspond to images. That is by design, the trained data set, right? We're not predicting anything yet. If I printed the first of these, so the images, the tensor images contains this and this and this and this. First of these is image 0, and its size is 12828 because it's a grayscale image. So one channel, 28 by 28. Is the structure clear? Oh, this is the structure you work with in Torch dataset. Images, 4. So, I mean, you'll be able to walk, you'll be able to index 0, 1, 2, 3. That's what you mean by asking for the dimensionality of images, right? You'll have, this is the first of them, this is the second of them, third and fourth. Try it out. So I'll give you this and you can try out. So my goal is here is to give you all the code so that you can try these things out for yourself. So you can next then tell me what is the size of images itself. What? Okay. Let's try that. In ndim, is that with parentheses or no? Okay, let's try. Oh, I might have to do my first code. So you see this little thing over here called connecting? It's connecting to a runtime, which means it's actually giving. Let me have to run my first one. You just have to do that once. I thought I had run this, but I hadn't. Okay, that seems to have run. That loop around it it seems to have stopped spinning. The output is over there. Let's run this. Okay. The ndim is 4. Yep. Does that make sense? But no, he's right. It's a deeper structure than that. So I'll let you figure it out in the lab. You can try this out. You can ask for things like size and shape of images itself. Just figure out what it is. Okay. You can access it using images and an index. That index can range between 0 and 3. You get one of the 4 images. English images here. Okay, does that make sense? Shall we move on? Okay, we have to stop at. Okay, okay, I'll do fast, and then you can stare at it at home. Okay, so this is at the. Here's my simple network. So I'm going to import a bunch of stuff, and I'm creating a simple class net. So notice this class keyword, the class keyword simple net, that's the name of this keyword. And I'm inheriting from nn.module. Okay, so you derive classes by inheriting from neural network module. That means it will provide you all sorts of keywords like nn.linear, .fc1, it'll provide you relu, softmax, and so on. So let's not worry about this too much. I'll cover this in more careful detail in the lab. What this is basically doing is creating a small neural network with 3 layers, and it's passing it through some ReLU functions, and then it is also carrying out some stuff. And that's it. Okay, and then you return X. So what that means is once you've operated on this, again, this is a function called forward. Forward is a function that needs to be defined in your when you're deriving from nn.module. What that forward does is it flattens out the vector. So you've got a 28 by 28 vector, which is 784, but it has shape. You flatten it out. Okay. This command called .view allows you to do that. This -1 is a Python thing that says, I don't know the sizes. I mean, compute the other dimension of this array yourself. And so 784 is 28 by 28, which means the other size is 1. You can again look this up in ChatGPT, or you can use your browser to figure out exactly what the syntax is saying. It's a very common piece of syntax. You pass it through a bunch of layers, and at the end of it, you return X. X was your data structure. And then I encourage you to find out what is the type of X. What do you think it is? Okay. In the interest of time, I'll move on. So here we are creating an instance of that class we just defined. All right. So, and I'm going to assign that to the model. So model is an instance of class SimpleNet whose input size I have defined to be 28 times 28, and number of classes is output 2. Does everyone see why this is? It's going to be a neural network model, which will take inputs of size what? 28 by 28. And what is its output going to be? One of the classes. So it is actually going to be the probability that the output is due to one, it belongs to one class, or the probability that it belongs to the other class. That's why there are two outputs. You can pick the greater of them as the probability that decides which is a likely class. Right? So the softmax operation is actually going to provide you probability that it belongs to one class or the probability it belongs to the other class. So it gives me both the probabilities of belonging to either class. Okay, and the final function is this function called the training function. Okay, let's just look at this one real quick. So we're going to define a function called train model. It's going to take in the model. Remember what is model? Model is the neural network SimpleNet. It's an object which is of class NN.module, right? So now you see the hierarchy is developing here. Okay. I'm going to take in a train loader. We just discussed what the train loader is. I'm going to take in what is known as the number of epochs and the learning rate. Number of epochs is basically tells you how long you should run, how long you should train for, and learning rate is how with what efficiency should you take steps during the gradient descent. I will describe these things again in the hands-on session. Okay. This says let's take so this is a line that tells you if you have CUDA, if you have a GPU, then CUDA, if torch CUDA is available, else CPU. So basically this line allows you to select a GPU if you want to. Model.to device takes the model and places the model onto a CPU or onto a GPU. So this is an important step which decides whether your model is on the CPU or on the GPU. If you're going to train on the CPU, but your data is on the GPU or vice versa, it's not going to work. So you have to know the device your data is sitting on and your model is sitting on. Most people will recognize that if the data has to be transferred from the CPU to the GPU, then you'll transfer the data, but your model also has to go to the appropriate device. Why not have the model on the GPU at all? So then what would run? So you have to pick the right device. And device is either GPU or CPU. You don't have to worry about this if you don't have a GPU, CPU selected by default. But if you are going to use a GPU, then you have to transfer both model and the data onto the appropriate device. Okay. So now this says for epoch in the range number of epoch. How many epochs did you want to run? Right? You set up a counter called epoch. Do a model.train. So model.train is provided to you by Pytorch library. So train the model for one epoch. Okay? Or one by one epoch. One epoch means I have run my entire data set through the training. I'm running it in batches. If I run it in batches, I'm going to send this batch and this batch and this batch. When I'm done with all of that, that's one epoch. Okay. Then this is just some some card counting to keep loss. This is the interesting sentence for inputs and labels in train loader. Inputs send it to device, labels send it to device. Then you run the optimizer. The optimizer is what is actually carrying out the gradient descent for you. Run the optimizer by starting with a zero grad step. Zero grad step is a technical step that's needed. If you want to run the optimizer, you have to zero the gradients to begin with. Let the whole thing compute, and then zero it again. Okay. This sentence, this line, this statement tells you I'm taking the input and applying the model, the neural network that we created, the instance that we had created, SimpleNet instance called model that we had created. We are applying it to inputs and getting some outputs. Then I calculate the loss. The loss is a criterion. The criteria could be, mean squared loss or MAD loss. Again, when we go to the hands-on session, this will become much more clearer. You're comparing the outputs to the labels through the criteria you're looking for, computing the loss. Then you compute a backward loss dot backward step, which allows you to change the weights based on the loss that is being computed. And then you step the optimizer. The optimizer step means the weights are now changed. The gradient descent says, compare the loss, send it back to me. I will decide based on this loss how much to move in my loss space. And then you move towards the loss space. You're looking for a minima. Okay? And then you run it and compute some stuff. Let me show you what the output looks like. So the output looks like this. Okay? You've got a number of epochs. A learning rate is how fast you're moving through the loss landscape. This is the call. That was the definition of function. This is the call of the function, right? And then this is the output it gave me. It says epoch 1 of 3, the loss was such and such. Epoch 2 of 3, the loss was such and such. The loss seems to be decreasing somewhat. Okay? And then training finish. That's your training step. Okay? That's how you train. Okay? And so that's essentially taking the training data set, putting it through the paces so that based on the training supervision, based on the supervised data set, you train your weights to find a minimum in the loss landscape. Does that make sense? That's what's going on. Okay, and then I'm going to show you. I just did this. Okay, then I want to show you, if you want to test the model, you can run through the same steps. And this stuff here, for example, if you wanted to know the input size of the inputs, I can use inputs.size and I can print it out. If there's or I can use shape. Like outputs also have a shape attribute. I can use the shape attribute and print that out. These kinds of lines are very useful when you want to know the shapes or the sizes of the objects you're playing around with. Okay. Yeah. So the other thing that I want to point out is, this time you're going to run with Torch, no grad. When you're running a training system, you have to keep track of the gradients as they are being computed in the computation tab. Okay. When you're running the test, all you're doing is just send the image through, compare the output. I don't need to keep track of the gradients. The gradients are what are used to redefine or refine the weights. I don't need to refine the weights because I'm done training. Once my model is fixed, I want to test its output, then I don't need to run gradients anymore. No need to compute gradients. During testing, that saves memory, it saves time. Again, you run the whole thing through, and I put out some predictions. Again, this is the actual call, the test loader. Test the model is the actual call, using the model on the test loader. Okay. And lo and behold, I sent it a batch of 4 values and the ground truth, and they came out to be brilliant. I don't know if it's right or wrong. You'll have to do a lot more effort to get. You have to put in a lot more effort to figure out whether the outputs are reasonable or not. Okay? That's the whole point of not relying blindly on what the output of code is. But that's where all your scientific creativity comes up. Right? But in this case, all 4 are matched. How nice. Again. So that's basically what a Pytorch run is. I hope you understood most of it, at least from the point of view how code is structured in Pytorch. If there are any questions, I'll give you this notebook. You can play around with this notebook. You can try out various other things through it. Again, it's a very simple network, okay? And there are no guarantees that the output is meaningful. Could be. So I'll let you discover for yourself whether the output is meaningful or not. That's one of the exercises that you should do. And when we come back, I'll tell you a lot more about how to write code, which has a much more difficult or much more sophisticated network and what else you can do with it. But this is basically the format of a Pytorch script to train and then check your prediction. Any questions?
Any questions?
When you actually do it in the hands-on session, it'll become a lot more clearer. But I hope you followed through and recognized some of the Python class and inheritance ideas and the functions and things like that that we talked about in the first tutorial.
So I missed this. Have you already shared the notebook? Or?
I haven't. I should
Okay.
do it.
Maybe right now, if you can make a tiny URL and write it on the board, people can play with it.
Okay. Not sure.
Or do it, during the lunch break so that people can.
Yeah.
That might be the quickest way to share.
Okay, I'll do that in the lunch.
Okay. Thanks, everyone. We'll meet again at 2. And
thank you.